So now we'll talk about something else. Uh, we have finished clustering, but something related to clustering is what we are going to cover in these next two topics. Okay, and this is called type of data in clustering. Okay, so what we will first look at in the first part of the lecture is how to deal with something called binary variables. We have so far looked at the case of what is called interval scaled variable, and I'll talk more about it. But if you deal with a different kind of a variable in your clustering, what would you do? So let us just start talking. Let us not waste time. So far we have been dealing with what is called interval scaled variables, and we will be talking about binary variables. So what are interval scale variables? Interval scale variables are continuous variables that can have numeric numbers, continuous real numbers. Okay, for example, weight can be, you can see weight can be like 5.2, right? 5.2 kg. So these are real numbers, which means that it can have a fraction, an integer plus a fraction portion. Okay. So height, again, temperature, coordinates, location, all of these can be represented by what is called continuous measure. These are all continuous measurements, and these are called interval scaled variables. So far, so good. You're all following me?
Yes.
Okay,
Yes.
so now one of the things that would like to mention is that if you're dealing with interval scale variables, just something very small to begin with, uh, and let me just talk about two measures. Okay, height in centimeters. Okay, and weight in kilograms. Okay, weight in kilograms. So what you'll get here is in like maybe 70 kg and 50 kg and 50 and like 90 kg, maybe something of in the order of tens, right? But when you talk about centimeters, you'll have something in hundreds. I don't know, 5 feet, 5 or 6 feet in centimeters. How much? Can somebody do a quick Google search and tell me? Let's say your height in centimeters. Uh, feet to centimeters. I wanted to show you to show something. Okay, so 6 feet. 6 feet is 182. So you're talking about 182, 180, right? 175. If you notice, do you notice any difference between the first column and the second column? Do you notice any difference between the first column and the second column?
The second column is by 100.
Yes,
First
and the
is by
first
10.
column is by tens, right?
Mhm.
So you have noticed that. So in clustering, if you see a difference like this, that for example, one is in tens, the other is in hundreds, and maybe a third one is in not just hundreds, but it could be in thousands. Income in Saudi riyals, right? 25,000. So there is a problem when you have such differences in clustering, which is when you have this difference, which is called difference in scale. So hundreds, thousands, tens, these are called scales. Okay. When you have these differences in scale, it will affect the outcome of your clustering. Why? Because the bigger numbers will dominate your clustering results. The bigger the numbers, so weight will dominate less. And for example, salary will dominate more in terms of creating the clusters. So do you understand the problem? That bigger
Uh,
numbers,
could you repeat? Could you repeat?
yes. So what I'm saying here is that imagine you have three variables in order to do clustering. This is X, this is Y, and this is Z. Now, what I'm telling you is that the Z scale is much higher than the scale of Y and the scale of X, right? You can see that Z is in thousands, while X is in tens, sorry, and Y is in hundreds, right? So Z is in tens of thousands, so the scale is much higher. So if you have a scenario like this, then in clustering, those bigger scale numbers, they tend to dominate in creating clusters, which is the problem. Because for me, I wanted to give equal weight to, the weight, the height, and the salary. So do you understand the problem now, what we are facing?
Mm-hmm.
That their scale has to be the same for them to be of equal weight. So what is the solution? The solution is called standardization. So what do? You do standardization, which means that you do a little bit of a conversion. Conversion meaning that all numbers will then vary between 0 and 1, not between like 70s and 90s and 10,000s and 20,000s and 180s to 190s. We'll do scaling such that all of them, those numbers will become the same. Now, I'm going to go out, but I'm going to show you because this formula looks a little complicated. So I'm going to show you the example of this in Excel so that because then it will be easier for you to understand. I'm going to take the same example and I'm going to show the scaling process in Excel. Okay, so I'm going to put the same similar numbers there. Just give me a second. The Excel is opening now. Let me just close some extra windows here. Okay. Okay. There's some background processes going on, so it is making it very, very small. So wait. Okay. Can you all see it on the screen?
Yes.
Height, salary. Okay. 15,000, 25,000, 18,000. Three people. Okay. Height 182, 190, 174, and the weight is 72, 85, and 68. Okay. At least can you see the difference in scale? Can you see the difference in scale?
Yes.
So now what we will do is we will do standardization. So first thing what we need is to take their average. You know how to take average, right?
Yes.
All of you know how to take average?
Yeah, the sum of them divided by the number of
Yes,
units.
just like this, we can also take standard deviation. Standard deviation of these numbers. Do you know standard deviations from your statistics course? Do you know how to take standard deviation, brothers?
I forgot.
Okay, I'm going to show you once. Okay, standard deviation of the weight. Okay, let's see how this thing is taken. So what you do is you're going to take absolute difference between the variable with its mean, okay? So I'm going to do this for all the values. So you can see here, I'm taking different, sorry, just a second.
What did you do?
I'm going to show you just in a second. Okay, so what I have done here is that, sorry, my bad, doing it the wrong. Okay, so do you know what is the weight now? 72?
Mm-hmm.
What is the average weight?
75.
Okay, so what you have to do here is that you have to take the difference between this weight minus the average weight, which is 75.
Okay.
Okay,
Mm-hmm.
and then you will have to repeat this. But this time you have to remember that you have to take absolute difference, not the actual. Okay, Now I'm going to do the same here again, okay? This time absolute difference between weight minus the average. Again, I'm going to do it again, okay? Absolute difference between the weight and its average. You following me?
Mm-hmm.
Now, all you have to do is to take the average of, what you just found, the differences, okay? Okay, so
Okay.
this is called standard deviation, okay?
Okay.
Okay, so just like this, you have to find standard deviation of height and then standard deviation of salary. Okay,
So
so I'm going,
we subtract 182 with 182 is 0.
yeah, let's see. Okay, right?
Yeah.
Can you see this?
Mm-hmm.
And then you take average, average, average.
Mm-hmm.
So everybody is okay with that? You all understand how found the standard deviation? Yes, Said, you're okay?
Yes.
Said, okay. Now I want you to give scaled value of my three variables. Okay, scaled value of height and scaled value of salary. So the formula for finding scale is value minus mean over standard deviation. So what you're doing here, I'm going to take the actual value of weight minus its average. Okay. And then I'm going to divide it with its standard deviation.
It should be by
Yes,
negative or it should be positive, the result.
it is between zero, minus one and one. All values are between minus one and one. Do you see that now all values are between minus one and one?
Mm-hmm.
Meaning minus one, zero, one. All values are now ranging between minus one and one. Is there any value? Oh, maybe this one is slightly outside. So let me check. I'm not sure. It should be. Maybe it's between,
And because there is 1.5 out.
yeah. Maybe I forgot, it should be between maybe three, three. Maybe it should be minus three and three. Yeah, sorry. It is basically scaled. Okay.
How
But
can
at
we
least
identify?
that doesn't matter. What is important is they are there are what is important for you to see is they used to be like in tens, hundreds and thousands, 10,000s, right? But are they of different scale now? This is the point that I'm trying to make.
Mhm.
Are they of different scale or of the same scale now?
Uh, the same
Scale,
scale, I
scale.
think.
Yeah, they
The
are
s-
same scale. Why? Because this was in 10,000s, right? This was in 100. This was in like tens, right? And now this is all like in like digit or fraction, right? Very close values to each other. So they will not affect each other. Okay. So this is called standardization. This method that I just showed you is called standardization. So let me repeat quickly. So you take your value, you find its mean first. Okay. So we have three variables. We found three means, and then we found three standard deviations. And we just have to use this formula. What is the formula? The formula is the value You can see here minus its mean divided with standard deviation. That's it. You can see it here. Let me just double click on it. You see here that 72 was the value, the mean was 75, and the standard deviation was 6.6. Let's try another one. You can see that 190 was the value, 180 was the mean, and 5.33 was the standard deviation, right? So it is just scaling. Everybody understand this scaling part? Okay, I hope
Yes.
so. I hope you understand the scaling part. So let's just go to the situation where I think you're using chat, so let me keep it there. Yes. So let us just go to binary variables. Binary variables are a different kind of variable. You know how binary variables look like. We are talking about variables that can take only two values. They can either take 0 or 1, or yes or no, or good or bad, right? So any two values. So first of all, when you're dealing with binary variables, where let's say if you deal with gender, so you always can convert this into 0 and 1. Okay, so that is not a problem. Any whether you call it good, bad, or big or small, or male or female, you can always convert that into 0 and 1. So that is the first thing. So uh, as I mentioned here, uh, we we are dealing with now, we are talking about dealing with binary variables. Can you see my mouse moving on the screen?
Yes.
Okay, sure. So now to deal with binary variables, uh, in doing clustering, the problem when you deal with binary variable is slightly different. The differences or the dissimilarity is calculated in a slightly different way. Okay. So in order to understand this thing, you need to look at, I don't know why okay, let me just go to full screen again. Okay, now I can see my pen. Okay, so you need to know four things: Q, R, S, and T. Okay, imagine that you are facing, uh, looking at two objects, two people, for example, two people. And I'm going to show you examples so you'll be able to understand. So we have two objects, okay, and we are trying to see how many of their characteristics match. For example, same thing, uh, maybe the gender of a person, okay, maybe the nationality, whether the person is a Saudi or a non-Saudi, okay, a Saudi or a non-Saudi, okay. You can see that this is binary, and maybe a third one or the fourth one or the fifth one. So what you do is you compare characteristics of the first person and the second person. And if their characteristics are one and one, both are male, one, one, then Q becomes plus one. You need to look at an example to understand it better, okay? So you give everything a name. So if, for example, in gender, male is one and female is zero. So it means that when both male is one and female is zero, then what you will have here, the Q will become plus one if both objects are male, both one and one. But if the first person is male and the second person is female, zero, then which number will go up? Which number will counter will go up? Q, R, S, or T? You understand my question? You understand my question or not? Okay.
Yes,
So
but
Q, R, S, T are counters. First of all, do you know what counters are? Counters are like you count 1, 2, 3, 4, 5, 6, 7. These are
okay.
counters for matching or not matching, matching or not matching. Whenever something match, one of these counters will go up. Whenever something doesn't match, some other counter will go up. That's like musabbah, right? You tasbih, right? So you count. So these QRST are counters. So imagine we have, if one of the characteristics is male, and you say male is one, female is zero. Okay. Now, if the first object or the first person is male and the second person is male, so it means that you're looking at male 1, female 1. Do you agree with that?
Okay.
Because both 1 and 1 matches, it means that the counter of Q will go up by +1. Okay, so the first two people were both male, so it goes up. But imagine if the first person was male and the second person was female, not the case as before. So which
R
counter
0.
will go up? As Hamad said, Hamad, you correctly said, first person is 1 and the second person is 0. So which counter will go up? R, which means that R will become +1. I'm going to show you example, you'll understand. So don't worry. You need to look at a proper
Okay.
example and then you will be able to understand it better, right? So if the first person was female and the second person was male and the second person was male, so which counter will go up? Female is 0 and male is 1. So S, that's correct, Hamad. S, this counter will go up. But what about both were females? Female, female, which counter will go up? T, exactly. So, and then Q plus S is the sum of these two. R plus T is the sum of these two. You can see here Q plus R, S plus T, these are the sum. But what about P? P is the sum of
All.
all counters. Okay. Now you may not be able to understand fully. You can see it down there as well. You can see down there that P is the sum of all counters. Let me show you an example, and then I'm going to come back to this formula. This is the only thing you need to understand. Rest is pretty simple. Okay. Let me give you a very quick example here. Okay. So how many objects are here in this example?
3.
3. How many characteristics they have? How many variables are we considering? 7. All of these the thing that you're looking at are binary, meaning that you're trying to identify similarity between patients. So the patient can be male or female, right? Fever can be yes or no. Cough can be yes and no. Test 1 can be positive or negative. Test 2 can be positive or negative. Test 3 can be positive or negative. Test 4 can be positive or negative. So let's say male to be 1, female to be 0. Male to be 1, right? Yes is 1, no is 0. No is 0. So I'm coding now. Okay, I'm coding now things. I think it's very easy to see why I'm putting positive is 1, no is 0, right? So 0, 0, 0. So all negative. Test 2 came negative for Jack, Mary, and Jim. Test 3 came negative for Jack, positive for Mary, and negative for Jim. And then 0, 0, 0. Now, I told you before that, let me just write here, QRST. I told you that if 1 and 1 matches, that's like counter go up will be Q. If it is 1, 0, it will be R. If it is 0, 1, it is T. And 0 is, you can see here, this, sorry, this is S, my bad. This is S, and like 0, 0 is T. Okay, 0, 0 is T. Let me delete this and write S again because it looks very dirty. Okay, let me write this again. S. Now, I wanted to find the difference with the dissimilarity between Jack and Mary only. I'm beginning with the Jack and Mary example, okay? So I'm drawing this circle around them. So what is Q? What is Q? When the Q is when both are 1 and 1. Do you all understand that? Chat
Both
box,
are
please.
both are
Both are
male.
1 and 1. So how many do you see 1 and 1 here between Jack and Mary? Is this 1 and 1?
Yes.
No, it's not 1 and 1. See carefully again. 1 and 0,
1 0.
right? Is this 1 and 1?
Mm-hmm.
Is this 1 and 1?
Yes.
Is there any 1 and 1 you found?
No.
How many? So how many Qs you have found? Two of them.
Two. Two.
So what is R? 1 and 0. 1 and 0. Is
One.
this 1 and 0? 1.
Yes.
Is there anyone else?
No.
Is there anyone else? 1 0, 1 0, 1 0, 1 0, 1 0, 1 0. No, right?
Mm-hmm.
Only one of them. What about 0 and 1? What about 0 and 1? What about 0 and 1? Is this 0 and 1? No. 0 and
No.
1, 0 and 1, 0 and 1.
One.
Only one. Right? Do you see this? This is the only one. What
Mm-hmm.
about 0 and 0?
2. 3. I mean.
3,
Yeah.
3. Right? So altogether, how many of them are there? 3 plus 4 plus 5 plus 6, 7. Do you notice that we have like 7, 1, 2, 3, 4, 5, 6, 7. 7 variables, so total is 7. Now, I want you to tell me when both, which one of the case between Q, R, S, T, when things are same? When both are 1 and 1, does this mean they are same?
No.
Like male and male. The characteristic match or not match?
Not much.
Why not match? When you're male and the second person is male, isn't this a match?
Uh. Yes.
Right? So 1 and 1 means 1 and 1 means what? 1 and 1 means it's a match situation. What about 0 and 0? Is this a match situation? Do you think it's a match situation, 0 and 0? Why? Because 0 and 0 is like you're saying female, female, or not positive,
Mm-hmm.
not positive, or positive, positive, or no, no. So it's match. But what about 1 0 or 0 1?
Not
Not
much.
matching. Hamad, then I'm following all of you, so you're able to see this very clearly. Not match. So this is like not matching. This is like not matching. So which one between Q, R, S, T we are looking at not matching? So R and S are not matching, and Q and T are matching. Do you all understand that? Do you all agree with that? Q and R are the counters when they were not matching.
Yes.
Sorry, R and S. Sorry, my bad. R and S is when they were not matching, and Q and T when they are matching. So do you all agree with that?
Yes.
So let's look at this formula now. Now, dissimilarity is the ratio between those characteristics which were not matching over all of the characteristics. You understand this formula? It is those characteristics which are not matching out of all the characteristics. So how many are the all characteristics? 7, Q plus R plus S plus T. You can see that 7 characteristics. So how many of them are not matching? How many of them altogether are not
2.
matching? 2 of them. So how would you use this formula? You're going to do
2
2.
divided by 7.
That's how you calculate dissimilarity. So 2 characteristics are not matching out of 7. Okay. So this is exactly how you are computing, the formula here. Okay. So this is how we calculate dissimilarity in binary variables. Now, sometimes what people do is, uh, they call it mono, not binary, but mono, from the word mono. Do you know the meaning of the word mono? Do you know the meaning of
No.
yes, mono means one. That's excellent, Abdulaziz. Mono means one. Mono variables are, can you see this formula? R plus S over Q R S T? RS plus Q plus R plus S. There's T gone. So what does T represent? The T represents 0, 0 situation. So these are the situation when you're only concerned with one ones, not like zero zeros. So this is like a test, like in medical when the
Uh,
test comes, yes,
Doctor,
just second side. So when the test come negative, you don't worry. You are only worried when the test comes positive. A medical test come positive, right? So what is important to you is one, not zero. So if you face such a situation, then you ignore the T. That's the only thing. So in this case, what you do, in this formula, you have only ignored the T. That's the only thing. You don't use it in the total. That's it. And this is called asymmetric binary. The previous one was called symmetric binary. Symmetric, both 0 and 1 are equally important. But in asymmetric, like in an HIV positive test, only positive is important, negative colors, no problem. So because one is more important, so in this case, the second one, the not true or not coming positive is not important, so you can ignore that. So this is called basically
is it,
yes,
Doctor, is it mean that
yeah, sure. Say,
when we
ask question.
when we want a positive outcome, we ignore T?
Now, when we don't want positive, but we know that positive outcomes are more important than negative. For example, let me ask you, say the question. You go for a
Mhm.
medical test, right?
Mhm.
Are you concerned about test coming positive or test coming negative? For example, COVID test. You want it
Negative,
negative. I mean, you will be happy coming negative, but as a doctor, doctor will be concerned with what? Positive test or the negative test?
positive test.
Why? Because then they have to do treatment, right?
Mhm.
If it comes negative, class they say go home. That's not a problem. But if it comes positive, that's important because then we have to give you
Yes.
medicine. So it is
Mhm.
it is this situation where we are ignoring T. When positive is crucial, but negative is not
Mhm.
crucial. Okay. Now
Okay.
now just like dissimilarity, we have something called similarity. And similarity between two objects I and J is nothing but one minus or dissimilarity. So what did you get previously? 2/7, right? In the previous one. So that's what dissimilarity. If you want to find similarity between those two objects, so you just do 1 minus 2/7, which means that you will get what? 5/7. 5/7 is the similarity, which is like the matches. The number of 5 is the number of matches, right? So 7 into 1, 7, 7 minus 2, 5. And this is also called what you call the Jacquard coefficient. Okay, it is also called Jacquard coefficient. So if you understand this very well, uh,
Doctor,
yes,
uh, the last example about one minus dissimilarity when we want to find a similarity or what?
yes, when you want to find not dissimilarity, but you want to find similarity, then you do
Mhm.
just 1 minus.
Mhm.
Okay, and you are going to call it what? What is the name of similarity? We call it Jacquard coefficient. The name that you're seeing here, it's just the name of similarity. Okay. Okay, so let me just talk about this example here. Now, imagine in this case when you're not. I've asked you in exam explicitly that I want asymmetric dissimilarity for the same medical example. So what do? Do you see that the same problem we are doing it where, but we ignored just plus t. So we did not consider plus t here. Okay, we did not consider plus t here. So let's look at the difference between, let's take Mary and Jim. Mary and Jim. Let's take this example. Okay, let's see how many match. This is like 0 and 1. This is like 1 and 1. This is like 0 and 1, right? This is like 1 and 0. This is like 0 and 0, right? I hope you're all following me. This is like 1, 0, and this is like 0 and 0. Okay. So how many, again, let's just see, 1 and 1 is R, right? Uh,
Mhm.
what is this?
Uh,
Let's just look at the
1 is
formula
a
again.
Q.
Yeah, QRST. My bad. My bad. So it is Q. So it's Q, R, S. These are the three things, right? T we are ignoring. So how much is Q? How much Q do you find?
1.
Only one, right? Which is the fever. Okay, the Q becomes 1. What about R? 1, 0.
2.
2. We found 2, 1 zeros, right? 2. What about S? 0, 1.
1.
1.
I mean
Which one?
2.
The
2.
cuff. The cuff. Right? Although we are not calculating T, but there is
Uh,
only one
Doctor,
T.
the S is 2.
Say again.
The S is 2.
S is 2.
Mhm.
Sorry, my bad. S is 2. You're right. Because there is, yeah, this is 0, 1 and 0, 1. You're right. The S is 2. Okay. So do you see this formula down there? It's nothing
Mhm.
but putting, you can see here R plus S plus Q plus R plus S. 2 plus 1, 3, 3 over 4, which is 0.75. That's it. That's
Uh,
the similarity.
Doctor,
Yes,
R is 2 and S is 2. How it becomes 1 plus 2?
that's a mistake. R is 2. Is it R2?
Mhm.
1, 0, 1, 0. PN. Yeah, it's a mistake. So it should be 2 plus 2. It's just maybe when I was typing it, it was a mistake. Okay. So anyways, you find then like the ratio. I think maybe we miscalculated somewhere, but this is let's see, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1. I think it's okay. Okay.
And Doctor, Q always 1.
Why Q always 1?
This is my question.
No, it does not have to be. We just had only one match, YY. What about if all of them are
Oh,
YY? We just
okay.
have to count.
I understand now. I understand. Okay.
Okay, now if I wanted to find similarity, I just say 1 minus this, 1 minus this. Just this is Jaccard coefficient. Okay, 1
Mhm.
minus of this. This is Jaccard coefficient. So 1 minus 0.75 is like 0.25. Okay, 0.25. So that's similarity. And then just like here, just like here. Okay. So do you understand this thing? Now, for the other lecture, I'm not going to go into too much detail, but I'm going to just talk about few more things. Okay. There's something called categorical variable. Categorical variable are like binary asymmetric variables, but not 0, 1, but they could have more than two. 0, 1, 2, 3, 4, 5. For example, colors. Colors cannot be just, there can be two colors, they can be more colors, right? Red, green, blue, 5 colors, 6 colors, 10 colors. So in this case, the only thing that I want you to know is that you can just do exactly, you can find similarity and dissimilarity. And I want you to look at this Jaccard formula, uh, which is basically the difference over, sorry. So let me just go there and let me start looking at the file that I shared. Muhammad, have you distributed this file to the rest of the class? Right,
Yes,
Muhammad?
he
Yes.
did.
Okay. So let's just look at, first of all, let's look at these questions. Okay. This is called mixed variable example. Why? Because it has it has difference. It has categorical variable. Can you see categorical variable A, B, C because it has three? Low, high, urgent, categorical variable. So I need to give it like numbers here, like 1, 2, 2, 3, 1, right? I can always give numbers. I'm going to come back to how we do the similarity matrix in a second, okay? 1, 3, 2, 2, 1, right? So that's how you first you put them numbers. That is one thing, right? Now, how to find dissimilarity in such cases? I'm going to show you, a small example so that you would be able to understand. So the formula is P, uh, what is the total number, and M, total number of characteristics, and M is the number of matches. It is the same formula. Total number of variables minus matches will give you unmatches. This, you understand that? P minus M will give you not matching, and P is the total number. So
Okay.
let's look at one example here with one variable only. Okay, I'm going to then go back to that example that I've shared with you. Now I wanted to find differences between, so how many objects are there? 1, 2, 3, 4, 4 objects. And it is doing a test which has 1, 2, 3 levels, right? So I'm going to call it just like this: 1, 2, 3, 1, right? We can do coding even. So uh, you just have to find the number of how many, first of all, how many variables are there total altogether. There's only one variable, right? Which is the test one, correct? Test. This test is the variable. Are you all with me? In this case, how many variables you have? In this case, how many variables you have?
Three variable.
Three variables. Okay, so just I'm going to take example from both the examples together so you can see the difference. Okay, so we know that P, which is the total number of variable, is 1. Okay, so let's look at here. So out of these three variables, between the two of them, let me just take this example here. Okay, uh, sorry, not this one. Here, I'm going to copy this table here so that you can just see it on the same screen. Okay,
Doctor,
yes.
how it becomes the Q here is 1, P1, I mean.
P is the number of variable. How many variables are you trying to compare? This object 1 and 2 is compared based on what, Said?
Uh, Number.
No, it is based on test number 1.
Okay,
So it's only one test. Imagine,
okay.
compare it here. How many, this 1 and 2 object are compared based on what?
3 tests.
Yeah, that's what I say. So P here, in this case, P here is 3. Okay. But P in this case is only 1. You can see that P is only 1. Okay. Is that okay, Said? Are you okay with this? Said, are you with me or not?
Yes,
Okay. So between so how many levels do you have?
3.
3 levels, right? So let us just see. Is 1 and 2 a match? Do you think the test values between object identifier is matching or not matching?
Not much.
Not match, right? So let me even bring this here. So when it does not match, you call it dissimilarity, right? So that is why this D21, we have written it to be 1. Do you see this one here? Because 1 and 2 are not matching. And it's only one characteristic not matching. That's why we wrote 1. So 1, right? So we wrote like 1. What about 2 and 3? Are they matching? 2 or 3, are they matching?
No.
So you wrote 1. What about 1 and 4?
Yes.
So there's no dissimilarity, that's why we have written 0 here. Okay. So let's look at this example. I'm going to take one example only. Okay, one or two of them. What about these two? How many of their characteristics are matching out of 3? Is this matching?
No.
Is this matching?
No.
Is this matching?
No.
So that's like, it's like 3 is like not matching. But what about 1 and 5? Let's look at 1 and 5. How many are
Yes.
matching?
2.
Only 1 is different, right? So that's
Mhm.
like the difference is 1, only 1. You understand how we are calculating this? Previously difference was 3, now the difference is only 1. Okay, so 3 divided by 3 and 1 divided by 3, because there are 3 variables only. Okay, so 3 divided by 3 means 100% mismatch, 100% dissimilar. Here it's 33% dissimilar.
Mhm.
Right, do you understand that? Okay, for example, here, where is that? When you actually have to divide it with p as well, so you will
Doctor,
see here that yes.
could you go back to the slides?
Yes.
Here, the 0 means no match.
No, 0 means perfect match.
Oh, perfect match.
0
And
means zero means there is no dissimilarity. 1 means total dissimilarity. Because the bigger the D, the more dissimilar they are.
okay.
Okay, so 1 means they are dissimilar, 0 means they are not dissimilar. See here. Let me just copy this. Let me just do undo, 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 and let's look at this again. We are comparing this and this, right? And then we are comparing the first one with this one. When you compare
Mhm.
the first one, how many were mismatches? Three out of 3,
Mhm.
right? So 100% they are dissimilar. Out of 3 characteristics, can you see it? See it here, all of you? Out of a total of 3 characteristics, all 3 were not matching. So 3 divided by 3 into 100, 100% dissimilar. Is that clear to everyone? So what
Yes.
about the first one and the fifth one? How many were different? Only
Uh,
test 3 was different, right? Only
yes.
test 3 was different. So only 1 out of 3 was different. So 1 out of 3 into 100, so 33%. So there's a difference, only 33% difference between 1 and 5,
Mhm.
right? So you understand how we are calculating that? Now, if we ask you to find Jaccard coefficient for this above example, okay, which is similarity, right? So what do? 100 minus the dissimilarity, or because I multiplied by 100, percentage is easy to see, okay? So Jaccard coefficient for the first one is 0, and the Jaccard coefficient here is 66%.
Mhm.
Okay, is that clear?
Yes.
So this is called, this is practice sheet. So you already now know how to, a question like this might come in the exam. Okay,
And oh,
can you take please screenshot of it, because I did not add the solution on this sheet. So I want you to take please screenshot. Muhammad, can you take a screenshot and maybe share it in your WhatsApp group? Because you can see the solution. Okay, done? Okay, done. Excellent. Now let's look at more
Doctor,
examples of Jaccard similarity. Yes.
what does the question means if you find feature for each.
So what is the question? Identify each type of feature. So this is the way you write it. I already told you this is what? Categorical. This is also does not look binary, right? Categorical. And this one, what is it? This is interval scaled. That's I showed you in previous things. Scaled, right?
Okay. Mhm.
So basically this is basically you just have to tell the types.
Mhm.
You just have to tell the types. Okay. Okay. So now both. This is basically the type and dissimilarity. I showed you this is like finding dissimilarities. Okay. 100% is similar, and this is like 33% is similar. Now let's look at more examples from Jacquard coefficient. So now you have to compare. Okay, Jacquard similarity. So you first find dissimilarity and then you find similarity. This is what you do, right? So what is the difference between, so there are two things, binary vectors. I already showed you in binary. How many total are there? 1, 2, 3, 4, 5, 6. Out of 6, how many match? 0, 1 match, second match, 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 match. All of them match, right? You
Why?
see that there's all of them match. So 0 out of 7 into 100. So 0 dissimilarity. 0% dissimilarity, right? Which means that Jacquard coefficient is 1 minus dissimilarity, 1 minus 0, which is like 100% similarity, or Jacquard coefficient is 100%.
Doctor,
Yes,
I did not understand.
we are comparing binary of Q with P and Q, 0, 1. Sorry, my bad. I think I did something wrong. My bad. So 0, 1, is it matching? No. My
No.
bad. Sorry, please undo. 0, 1 matching? No.
No.
1, 1 matching?
Yes.
1,
Yes.
1 matching?
Yes.
0, 0 matching? 1, 1 matching.
Yes.
So my bad. Sorry, I thought I did not read it carefully. So how many are not matching?
Not much. 2.
Out of 7 not matching, right? So 2 out of 7 is how much?
Out of 6.
Out of 6? 1, 2, 3, 4, 5, 6. My bad again. I think I'm too tired now. 2 out of 6 is how much? So 2 divided by 6 is 33%,
Yeah.
which means that this is dissimilarity, okay? This is dissimilarity, okay? Which means that Jacquard coefficient is how much? Yes,
66%.
yes. So it is going to be 1 minus 33.33%, right? Which is equals to 66.33.
66%.
So you know how to calculate that. Now, this is a different kind of a problem. Okay, so this is a slightly different problem. So I'm showing you different kinds of problem. Let's look at this problem. Okay. So if you're given sets, just keep in mind I'm talking about when given sets. Okay, when given sets, how to deal with that situation. Okay. So in this case, you find the total set, which means that total set is how much? 0, 1, 2, 3, 4, 5, 6, 7, 9. This is the total set. You all agree? Have I missed anything?
No. From
Now
0 to 9.
yeah, if you have to find, I'm going to show you here in a website where it says intersection of A and B over union of A and B, right? So intersection means what was common. So what is common? Common between them. What is the common set?
0,
What is common in both? 0 in
2,
both,
2,
2 in both,
5.
5 in both.
Yes,
That's it.
that's it.
That's it. So what is dissimilar? What is Jacquard coefficient? It is the formula is common over total set, okay, which is equals to how much? 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 over 9, right? Which
Why?
is see, count how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
Mm-hmm.
And how many are common? 1,
3.
2, 3. So
Mm-hmm.
because we are talking about common, not uncommon, dissimilarity. So you're directly calculating Jacquard, okay? So 3 over 9, which is equals to 1 over 3. This is
Yes.
1 over 3, which is equals to again 33.33%. Okay. Now,
Mm-hmm.
if they ask you about dissimilarity from here, what do? It is 1 minus
What?
Jacquard. Yeah, just
Mm-hmm.
you do 1 minus. So which is equals to 1 minus 33.33%, which is equals to 66.66%. Okay. So this is again another example. You can take screenshot and share. Can you just give me 1 second, please? Yes, sorry, I had to take this call. Some important call was expected. So, do you understand? So, have you taken the screenshot? Muhammad, have you taken or someone else has taken the screenshot for the solution? Okay, done. Excellent. So, I'm just showing you practice problems. Dissimilarity between hierarchical clustering, just look at the slides. Ignore this problem. I don't think we would like to give this. Now, the rest of the problems you have already solved. I already showed you how to find dissimilarity matrix in k-mean, how to do k-mean clustering. Okay. So you have the rest of the problems, and we will not give you this big problem. This is just for practice, so do not get afraid. Okay. So just look at this problem. What I think, because we do not have another class, Muhammad, I want you to coordinate between others. See if you need me to review anything during the week. I will be more than happy to make a revision session, short revision session, any day of the week in the afternoon.
Yeah.
Okay.
Yeah. I think we need a revision class. So.
Okay, sure. But let's plan. Let's first discuss between yourselves. What exactly you want me to revise, k-means, k-medoids, anything, okay? And then we can do it before the exam. Okay? Anything else?
Oh,
I think we are good,
okay.
because these are just more examples from what we have done in k-means. You have already seen it. Okay?
Okay.
If you do not have any other question, we can stop now.
Doctor,
Yes.
if I did not understand this question, can me and you, have a session like with
Which
you?
question are you talking about?
The question that we did not take here.
Yeah, it is exactly what we already did in k-means, just another
Yeah,
thing.
yeah, but just if I did not.
It's a good question. Just a second, Saeed. I'm not sure, Hamad, but I'll try to get this question from the course leader. Okay, I will check if she's willing to give, those Euclidean distance and Manhattan distance formula, etc. Okay, but I will check with her. Okay, it's okay, Saeed. If you have anything, let me know, and I'll try my best to find a time for you. Okay.
Okay, thank you.
Okay, thank you everyone, and inshallah will in case there's anything, please communicate to me via Muhammad. So okay, and then if need, we can do like a 30-minute, maybe a revision session sometimes in the week, later in this week. All right, everyone, please take care, and we'll talk again.